Okay, we're gonna start with number one. We're just gonna go in order. So if you need any help, please don't be afraid to ask. I do have the chat open, so if you have anything, just please text it in there. So first, we're gonna do the Boolean algebra question, and if you look at it, it seems really complicated because it's long. However, if you do it like if you simplify it, it's not that complicated, and that's the point of this question because you're trying to simplify it. So if you look here, we have a big knot, right? So we're gonna actually ignore that big knot for now, and we're gonna do everything inside first. So we have inside is AB plus not B plus C times A. And so first, the order operation goes parentheses, unary, which is like the numbers in between, and XOR or, and in this situation would be multiplication, or would be a addition XOR. You can see probably in number two. I'll explain a bit more in detail, but that's like kind of the order of operation. It's very similar to basic math where you do like order of operations where it's like division, multiplication first, and then yada, yada, yada. So to simplify this, we're going to simplify the not first, plus parentheses, times A. We're going to put that all in parentheses. You could do, I'm going to show you two methods. This is my preferred method personally. And then we're going to just simplify this A, B not, C not. And if you actually take this, it's going. And from here, to simplify it further, you could kind of delete it and such. But if you were to do that, it'd be very complicated. So a simple, much simpler method would be instead to like notice how I said in the beginning you can ignore the big knot. Instead, what you also can do is split up the knot A B knot, and instead of addition, since we knotted it, it's going to be the opposite, and it's going to be an and. So we're going to have this as such, and afterwards from here we're going to continue to simplify. Not A plus not B times a big knot over A, B not, C not. And from there, we're going to continue to simplify within the big unsimplified one. So B naught times A naught plus B plus C. And then we're going to distribute the not A times not A is not A. Not A times B is not AB. You know the drill. And then we see here not B times B. Not B times B is going to be 0 no matter what, because in this here, we're doing Boolean algebra, which means it can only be in binary. So the B is either a 0 or a 1. If it's not of each other, that means both are going to be either 1 or 0. And if you multiply 1 times 0, it's obviously 0. So we're just going to add 0 there and not B, C. So now we have to simplify further from here. And if you see here, we see a not A alone, and we have not A, B plus a not AC. What we can do here is actually eliminate this as like this, anything with not A. Why, you might ask? Because if we take this out, let's say we undistribute it, and it's going to be B plus C, 1 plus B plus C plus not B. You see here, there's a 1 right in the beginning. And if there's a 1, it doesn't matter what the rest of the numbers is, because even if it exceeds 1 in a binary, it's just another 1 in the higher position. So that means this is all going to be 1 and negative. Not A times 1 is not A. Why do I add the 1? It's because if you look here, I'm factoring out the not A, right? And this is not A. If you factor out like 2 from 2, you obviously have a 1 left, because that's how like factoring works. And in the end, you're gonna have not A plus not B, C. And that would be B. I know Marcus asked the question about why I added the one. If it's still confusing, please leave another message. Does anyone else have any other questions? All right, I'll take that as a no, and I'm gonna do the next one. So the next one, this question asks how many ordered pairs make the following Boolean expression true? Keyword true and how many pairs? We need to make sure we're gonna have to simplify this as much as we can, and then we're going to see what's true. And for finding what's true, we're going to use something called the truth table, which I will explain as soon as I get there. So let's try to simplify this. We see here something unfamiliar, right? That's what we call an XOR. Basically, XOR means they can't be the same. Basically, A, in this case, A has to be 1 and B has to be 0, or A has to be 0 and B has to be 1 for it to be true. So, but in very simplistic forms, it's A, B naught plus A, B. However, this is very complicated to like eliminate or undistribute. So what we're going to do is we're going to leave this side alone. We're going to leave the A not B alone. And we're actually going to just simplify this side. So it'd be not A plus not B plus B. And if you see here, we see a not B and a B. That means, and like I said before, if there's a not of something and the same thing, one of them has to be a 0 and the other one has to be a 1, no matter what, because they're just going to be opposites of each other. And that equals 1, because 1 plus 0 is 1, no matter what way you look at it. And 1 plus anything is going to be 1 when it comes to binary, since it's not multiplication. So we can eliminate that as well. So it'll be A, not B. And what we're looking for is any pair that's not the same, right? Like I said before, A either has to be 1 and B has to be 0, or A has to be 0 or B has to be 1. And if we use that logic I just used just now, how many pairs do we have? We have 2. There's another method you can use when you're trying to find if something's true or not. Chu and Sangsini has attached something called a truth table in the ACSL group chat, most likely. And if you can print that out and use it as a method of keeping track of what's true and not. That way it'll be much easier because you don't need to make your own table and count and stuff. And that's like really complicated. So there is one pinned in the Discord group chat. And I recommend you print it because during the actual ACSL contest, it is most likely that the program will detect if you switch tabs or not. So just to be safe, print it out. All right. Now we're gonna do questions 3, bit trick flicking. However, before I do move on, the junior division students, I do hope you can try doing the 1 and 2 on your own real quick. And I want the intermediate division students as well to do it, do the problem. And I want you guys to send me what answers you get. I will know if you just give me the answer immediately because like I understand how long it takes. So if everyone could try out the 2 problems, 1 and 2, junior division students on their own ones, intermediate division students on this one, it would be really appreciated. So I'll give everyone 2 minutes to try it out. So try it out and just send me a message and I'll tell you if it's right or wrong. And just know I might randomly choose one person and be like, how'd you get it? Just to make sure that you guys aren't just like copying my answers. And the junior students, just send me the answer. I'll tell you if you're right or wrong because yeah, I do have the answer. Keep it. So you guys have until 8:20 to try it out. Yeah, good luck. I'll give you guys another minute because I'm not seeing any answers in the chat. Just send it. I don't care if you're wrong. I can explain it again. I don't mind doing that. But please try solving it and then sending it in the chat. And also, can you please, yeah, thank you. Just tell me if you're junior or senior just to be just to make sure. Um Samuel, yes. Justin, that's number one. And yes. Uh I know there's more students than those who have messaged me. All right. I like how this is heading. I'm gonna go on to the next one. These concept these my bad. These problems focus on big streak flicking, and what I want you guys to do while I explain. I'm gonna explain the concept of bit string flicking through the first one, number 3, and then I'll give you like a method of how to do number 4, and then we're gonna do the same thing basically over and over again. I'm gonna do it. I want you guys to try it out and then give me your answers. So let's try this out. So what we see here in this is the problem of we see we have R shift 2, not R circ 6, LS1, R circ 12. So knowing this, we know that this is clearly not more than 12, right? See 1, 2, 3, 4, 5, 6, 7, 8. So we know there's 8. So what do? What we're gonna do actually is that we're gonna take these last 4 and put them in the front because it says L circ, and L circ means take from the right and circle around to the left. So the number would be 0. Number would be 0, 1, 1, 0, 1, 0, 1, 1. Now you may be asking, why did I take the last 4? Because when you do L circ and it's greater than the number, that means, let's say I did L circ 8, right? And there's 8 numbers here, right? What that means is that I quite literally took 8. If this was LCA, that means I took the 8 and then looped it again. And that means no, the order doesn't change when I loop it. So it just means I took it and then put it back as it was. However, this is 12, right? That means it goes 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4. And this 4 that I counted again is the chunk that we have to take. So we have 0, 1, 1, 0, 1, 0, 1, 1. And now the next course of action says L at L shift 1. So we're going to go 1 to the left. 1, 0, 0, 0, 1, 1, 0. I hope you guys understand what shift is. Shift is literally quite literally moving that much to the left or right, depending which one it is. And circ is taking that amount from each end and moving it to the direction that's indicated. L circ means take it from the right and go to the left. And R circ means take it from the right and take it to the left. So now that we have L shifted 1, we're going to have the right circ now, right? And since we have to take 6 from the left and take it to the right, we're going to count 1, 2, 3, 4, 5, 6, 1, 0, 1, 1, 0, 1, 0, 1. That is going to be the result of your R circ. Wait, give me a second. E 2, 3, 4, 5, 6. Shift give me sorry, that is on me. 1, 0. Yeah, my bad. Sorry, guys. You just take it here. You just take this and loop it around. And then now we have to complete the knot, right? And knot just means turn everything that was a 1 into a 0 and everything that was a 0 into a 1. So it'd be 1, 0, 1, 0, 0, 1, 0, 0. And then after that, quite simply, RS2, move to the right to be 0, 0, 1, 0, 1, 0, 0, 1. And that would be D. Sorry, I stopped in the middle. I kind of counted wrong. So that is my fault. Anyways, that's how you do number 3. There are my drawings. I'm going to get rid of it quickly because, yeah, I want to make sure. And then now we're going to do 4. 4 is a bit complicated in the fact that there is an unknown variable like we call x. And we're given how long x is, which is a 5-bit. And what we're going to do is instead of writing x here, we're going to replace it with A, B, C, D, and E. That's 5 for 5 bits. Now, with this information, what we're going to do is I'm going to share a whiteboard, guys. I'm gonna share a whiteboard so you guys can see it. So it's gonna be x is equal to A, B, C, D, and E. And what we're going to do is we know the original, what is it called? The original things, which is going to be RS1 0010 acting, or L circ 2 01110, and not 1010 is equal to L circ 1 R circ X. And using this information, we're going to solve the side that we know, the side we are confident in that we know because they're given as the answers. We're going to use that side as our, basically when you're finding like an equation in math, we're going to take that side. We have that known side that we plug in values to, and then using that side, we're going to find the unknown side. So our first order of action as of right now is going to be finding the side that we know. So like I said before, it was R shift 1 of 0, 0, 1, 1, 1, or LC2 for L circ 0, 1, 1, 1, 0, and not, I'm simplifying the letters so I don't, it's much faster like this. And using this, we're going to R shift 1, this one, because parentheses are always first. The order is parentheses, unary, which is like not and such, and, which is like the and symbol, XOR, the one that has to be different, and then it's 4. So knowing this, we're going to do the parentheses first, R shift 1, so 3, 1, or LC2, right? We're going to have the circle 2, 1, 1, 0, 0, and not, so it'd be the opposite 1 0 1 0. And then from here, what did I say? The and comes before the or in terms of order of operation, so it'd be 0 0 0 1 1. Or, and what does and mean in this situation? That means only the ones that are both 1 come down as 1. So in this case, 1 and 0, that's a 0. Because 1 times 0 is 0. 1 times 1 is 1. 0 times 0 is 0. 1 times 0 is 0. And same thing. 0 1 0 0 0. And since we have or just means that it has to be same or different, it doesn't matter as long as there's a 1 in there, because 1 plus 0 is 1, 0 plus 0 is 1. I mean 1 plus 0 is 1, and 1 plus 0 is 1. So the site that we know is going to be 1 0 1 0 1 0 1 1. Okay. Knowing this, let's solve the other side using the unknown variable that we have. So, like I said before, the unknown side is going to be A, B, C, D, or E. With this information, what are we going to do? We know it's LC2, 1, RC2, X. And X is A, B, C, D, or E. So LC2 is going to be LC1 RC2X becomes LC1. And then remember how I said X is A, B, C, D, or E? We're going to do that. And if we R circ to it, it's going to be D, E, A, B, C. And we're going to do LC1 again, right? So it's going to be E, A, B, C, D. With this information, we know that this has to equal 0, 1, 0, 1, 1. So let's order E, A, B, C, D is 0, 1, 0, 1, 1. So what was X originally? A, B, C, D, E. So let's put this in order. A was 1, B was 0, C was 1, D was 1, and E was 0. So the original X is going to be 1, 0, 1, 1, 0. With this information in mind, let's look at the option choices. Here. It's going to be none of the above, because we're going to have that one value that makes it correct. However, the answers are 0, 2, 4, or 8, so it's going to be none. All right. Now I want everyone, once again, to do questions 3 and 4, and just give me the answers in the chat. And then I'll just tell you if you're right or wrong. I'm trying my best to keep the reactions into the chat by saying like, oh, you got it right or wrong, not to like embarrass anybody. But I feel like that's taking a longer time. So I'll just say it out loud. And just know, guys, I'm not trying to embarrass you. I am just saying it simply out of speed. So I'll give you guys 2 minutes to try it out. And then we're going to do 3, 4. I hope everyone is doing your problems right now. I'm there. I'll give you guys another minute to try it out. Uh, yeah, okay. Justin, yes. Samuel, I think you were yeah, Reina and Samuel, yes. Julia, yes. All right, Park, yes. Okay, guys, I'm gonna move on now. We have a lot of questions to go through, and I don't want to take up all the time just doing problems. So we're gonna move on to some recursive functions. In the intermediate one, these two are quite complicated, but for you, the ones in the junior division, don't panic. It's quite the formats are quite similar, but just kind of different. Like the difficulty is different. I'm going to be sharing a whiteboard once again. I'm going to keep the original. I'm going to write the original problem, so don't worry. So we're told to find f of 17, and we're given f of x is equal to 2 times f of x minus 3 plus 1 if x is greater than or equal to 12, if f of x is like this, if 2x 12 and x minus 4 if x is less than 2. So you might be wondering what those brackets are. These brackets are like special little things that ACSL tends to add into the problem. And if you look at the bottom of the description, it says square bracket x is the greatest integer less than or equal to x. Basically, if I do x divided by 2, and let's say x was 5, 5 divided by 2 is obviously 2.5. However, because of the brackets, it would be 2 because it's the greatest integer less than the value inside. So knowing this information, knowing this info, we're going to try finding f of 17. So f of 17 is equal to, what is it? It's obviously greater than 12, so it'd be 2 times f of 14 plus 1. And then it'd be f of 14 is greater than 12, so it'd be 2 times f of 11 plus 1. And since we know f of 11 is between 2 and 12, f of 11 is equal to, and since it's in between, it's going to be f of 5 minus 3. F of 5 is between 2 and 12. F of 5 is equal to f of 2 minus 3. And we see here it's greater than or equal to 2. So it'd be f of 2 equal to f of 1 minus 3. And f of 1 is going to equal x minus 4, which is going to be 1 minus 4. So it'd be -3. So we're going to go up the chain one from now. So from here, we're going to go up. So f of 1 is equal to -3. So that would be -6. F of 2 is -6. And -6 minus 3 is -9. -9 minus -3 is -12. And we see we got to -12, right? Now, we have a new equation. 2 times -12 is -24. Add that to 1. It's going to be -23. And up. -23 times 2 is -46. Add that to 1, it'll get -45. And -45 is B. All right, let's continue on to number 6. Number 6 is quite complicated. I want to do this with the problem on there. So in the intermediate one, it uses quite some like difficult language. It says define Pisano's function, and you see here if n is equal to 1, 0. If n is equal to 2, 1. And then if it's greater than or equal to 3, p of n plus p of n minus 2, mod m. And we have to find mod. If for m, let's see, I put 2. Then every sequence that comes there, I just quite literally put in, we just mod the value by 2. And for here, it says, what is Pisano's period for mod 4? That means m is going to equal 4 here. And what is Pisano's period in this case? Let me show you. Pisano's period in this case, if we see here, is 3 because it goes from 0, 1, 1, and then it's on the fourth one, it's the same number again, right? The sequence continues. So in actuality, it's actually just m plus 1 kind of. But to prove it might actually not be m plus 2, m plus 1. It might not be like that. So we got to actually check how it works. But if you look at this very simply ignore the mod m. If you ignore mod m, if you look here, it's p of n minus 1 plus p of n minus 2. What does that seem like? Yes, in actuality, it's like, what is its name? You know, not Python, but, 1 plus 1 is equal to 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. That sequence, yeah, it's basically that. But instead, we added a mod to that to make it much simple, to make it a little bit more complicated. So knowing this, let's write a sequence. We know, what is it called? That sequence, Fibonacci's, sorry guys, Fibonacci sequence starts with 0, and then goes to 1, 1, 2, 3, 5, 8, 13, and so on and so forth. And what we're doing here is modding each of these by 4. And we're trying to find that Pisano's period, which is basically the instance it actually repeats itself. So if we try to do it, we're just looking for a repeating sequence. It's going to be 0, 1, 1, 2, 3, and this is I'm gonna tell you guys something. This is not actually supposed to be 4, but it's actually to be 3. It's meant to be 3. So I want you guys to try. If you look at it simply, it's just 0, 1, 0. It's gonna be 2. It's gonna be 2 again, because 3 plus 2 is 5, and 6 plus 2 is 8, and this is gonna be mod 1, and this is gonna be yeah, it's gonna be 1. And let's see how far we are. 1, 2, 3, 4, 5, 6, 7, 8. We've come here, right? And then let's go to 8, 21. It's going to be 0 again, right? And then we add these two, it's going to be 34. And if you do that, it's 1. And the numbers are going to start to repeat itself. So what do we know? It starts to repeat itself after 8. So the answer is going to be C. Sorry, guys, the problem does say 4. If we were to do 4, it'd be kind of more complicated. So I just did it with 3 because that is what was supposed to be given instead of 4. Instead of actually making you guys solve this, I want you guys to solve this on your own. Thank you, Fibonacci's. Yeah, I didn't see that. I'm gonna move on to digital electronics, and then we're gonna because at 9 we're gonna start doing something else. I'm gonna kind of go quickly. So for 7, we see here that we're trying to make a Boolean expression. So let's look at this simple. This D looking thing is an and. This weird thing is an or. So it's just a multiplication and a plus. And these little circles in front means not. So with all this information, let's start. So we see here A, B, not. And we have a B plus C not. And we're going to actually multiply those two, not A, B times B plus C not. And then we here have a plus sound down here. We're going to parentheses this, have a bigger parenthesis, and we're going to add that to C. So it says simplify the Boolean expression represented by a circuit, right? So we're going to simplify. Not A, B, it's not B, times not B, not C, plus C. Let's simplify this to, we're going to distribute not A, BC plus not BC plus C, and we know this is eliminated because of the distribution thing. And we see here not B, C plus C. Right? And we know if we could simplify further by eliminating this technically, but we see here our answer is A. Yeah, because we just quite literally simplified that, so it's not very good. Oh, and also for the previous recursive function, I can show you how to do it with for. It's not that much harder. I just want to make sure the intermediate students know. What I was explaining was actually the junior packet using this. It's basically the same thing, just with a different number. And we're going to do the same thing here. It's going to be 0, 1, 1, 2, 3, 5, 8, 13, and yada, yada, yada. So if we do mod 4, it's 0, 1, 1, 2, 3, 1, 0. And that's 1, 2, 3, 4, 5, 6, 6 up to here. And then why do I stop at 6? Because the pattern starts again afterwards. It's going to be 0, 1, 1, 2, 3, 1, yada, and so on and so forth. And since that pattern repeats itself, we know the Pisano's period is just this. I'm going to go on to the next digital electronic problem. I want you guys to all try solving this on your own. This one says, what will make all of the order triple true? We see here this weird thing is an XOR. So we're going to actually try to simplify this. So it's going to, this thing is going to be XOR B and then not B plus C, right? And this rectangle is something of the unknown. Our choices are and. Marcus, yes, I do know that. I did write 3. I might have misspoken. That is on me. This rectangle can either have an and or not and. Not and mean I write an and it just eliminates. There's a not on top, a not or that means there's not over it, and there's an or in between, or none of the above. So we can try this all out, but let's try making a true. We can use a truth table, right? We know these two have to be different no matter what, and we're trying to make the least number of ordered triples actually true. So we know this. We know B and C, one of them, for this to be false, we know one of them has to be like this, or like this. This one, for it to be false, it has to be like this. So with this information, we're going to try to find a way to make it not as true. So looking at this situation, we're trying to find a way to make it only one of them. We're trying to make the minimum number true. So we know for this case, for the XOR case, it has to be 0, 0, or 1, 1 to be false. I'm looking at false. You know what? Rather, let's look at true situations. That way it's much easier, simpler. So for this one, it'd be 0, 1 and 1, 0. For this to be false, it'd be 1, 0, 0, 1, or 1, 1. Using this information that we have, we're going to put in other things. We're going to try all 4 of them. Let's see which one makes the least. Let's put an and. If we put in an and, both have to be true. So, and we see that B overlaps. So it has to be either 1, 0, or yes. Wait, no. It's just going to be 1, 0, 0 to make it true for and. So we have a contender, 1. Or if we make an or, what works? We can do 0, since not all both have to be true. we have four possibilities: 0, 0, 0, 0, 1, 0, 0, 1, 1, and 1, 0, 0, and 1, 0, 1. That's four different possibilities. If I do not and, there's much more, because if there's three numbers and there's an 8, and only one of them works for when it's and, not means that it's going to mean 7 and this is going to be 4, because we're quite doing the opposite of this. So it's 7 and 4, and obviously out of this, the and is the smallest. This one was kind of complicated, but what you have to do for this quite literally is kind of brute force it and just try out a lot of things. Now, prefix, infix, postfix. This is very important because this does come out a lot like everything else. What we're doing here is says evaluate the following prefix. All numbers are single digit. So we know it's a prefix expression. That means it's in the one in front is going to be the one affecting it. So we're going to go in order 2, 8. That's 10. As tempting it might be to do negative 10 divided by 5, we're not going to do that just then. We're going to do everything in first order. So 3, and that's going to be 16. Then we go on to the next level. 2, 7, and next level 21, 18, -3, and the answer is A. That's how you do prefix, infix, prefix, and postfix. So resist the temptation to like go as far as you can before actually like solving each level one at a time. It's much simpler that way. Now let's move on to postfix. It says here, change this postfix expression to prefix. Knowing this, let's first make this into infix, which is just normal. So we see here 2 times 3. Then we're at 2 times 3. And we have a postfix. We're going to go like this. And 3 times 2 here. We have 2 to the 4th. And then we're going to go in order once again, 4 times. We'll multiply that by 4. We'll raise that by the second power. I'm going to add this plus 2. And then we see here we got to divide this by 6 because it's the big one here. And we got to divide these two, 2 to the 4th plus 2, and then subtract these two. So we got our final equation, right? So let's turn this into a prefix expression. So we're going to go in order the same way again. So we know 2 times 3 has to be multiplied. We know 3 times 2 has to be multiplied. We know 2 to the 4 has to be multiplied. We're going the same order. And then now what do? We know 4 has to be multiplied here. And since it's prefix, it's going to be like this. And the order of the numbers do not change in the end. And we know 6 is going to be divided here, but that's later. So we don't do that yet. So we do 2, and we put as the caret symbol. And then we also know that the 2 is going to be added to this. We're going to add a 2, and then we're going to go like this. And we know there's you divide by 6 here. And then you divide these two. So you put a slash here. And then we're going to divide everything as such. So your answer would be C. Yeah, it's quite complicated, but what you guys need to remember about prefix, infix, postfix is that the order is important. You want to keep a consistent order so you make sure you don't mess up. Now we're going to do computer number systems. Computer number systems are the ones that involve binary, octal, and hex. It's usually just going to be those three. It's probably not going to go beyond that. And the question asked in 11, there's always a word problem when it comes to computer number system. It says, when is the next year in base 10 after 2002 that the year expressed in octal will have 3 consecutive octal digits in increasing order? So we're trying to find, first step, we're trying to find the next year. So basically we have to find what the octal of 2002 is going to be. And the method is quite simple. It's quite simple. we're just going to continuously divide by 8. And if we do this, there should be a remainder of 3. You guys technically aren't allowed to use a calculator, but for the sake of speed, I'm just gonna do that quick. The remainder is not 3, actually, sorry, 6. It's 252. Divide that by 8, you'll have 8 is going to be 31, and there's going to be a remainder of 4, 8, 7, because it's going to be 3 divided by 3, it's going to be 0, it's going to be 3746. And when you change it back, it's going to be, you got to go from bottom up. So 2002 is 3746 in octal. And then, knowing this, we're going to find the next one with the consecutively increasing digits. So what we're going to try to, we see here is 3746. Obviously, these two had to be 8 and 9, right? That's what would be ideal. However, that would be that doesn't really work out. And so basically what you're going to try to do is you're going to basically brute force it, try to brute force it in a method, in a way, and then basically try to find the next one. And the next one you'll find is 40128. And if you convert this using by changing this into binary and then simplifying it, you'll get 2058 in terms of decimal. And guys, you don't need to ask if you want to use the bathroom. You can just go, just make sure you come back, because the test will be important. It's going to be important. Yeah. And your answer is going to be T because of that. And then you see the next format. Like you might be asking, oh, there's a bunch of different computer number systems. There's binary, there's like decimal, there's octal, there's hex. You don't need to think about all that. Just convert it to binary, change it to decimal, base 10, do the math, and then change it back into the base that you need to. So in this case, this would be 22 times A is going to be 10 divided by this is 11 minus 20 plus 36. How you convert it? You just quite literally, A is going to be 10 and is going to be 10. So if you want to change that into binary, it's going to be a 1, 0, 1, 0, and that equals 10, 13. The first number is going to be 0, 0, 1, and then 3 is going to be 0, 1, 1. If you guys don't know what octal hex is, that's kind of confusing. That's kind of like a little divot that I need to pass. 6 to the 8 will be 36, because quite literally it says 6. To make that, it's going to be 1, 1, 0. Square that, it's 36. If I'll kind of teach how to convert from, if you have a binary number like 1, 0, 0, 1, 0, 0, 0, and you're trying to change it into a octal, because this is base 2. Let's say you want to change it into base 8. You take 3 from the beginning, which is the end of the number, the rightmost, and you just keep on taking chunks of 3. You can have like numbers because there's just a leading 0 technically, and then you say 0. That's going to be 4 plus 1 is 5, and it's going to be 5050, which is just 50 in octal. And if you want to change it into a hex is being base 16, you take 4 instead of 3. Basically, it's the which power of 2 is what you're going to take. Knowing that, it should be much easier to simplify. And your answer for this 12 in here would be 24 if you like solve out all the math. We're going to move on to data structures. And it says here, was the internal path length of the binary search tree of delta. Before you start any binary search tree, first step, in the corner, right? C, B, E. Just write the entire alphabet. It's gonna be helpful. Trust me on that. Okay. Now that you wrote the alphabet, let's start. So how to build a binary search? So we're gonna go in order D. We'll start with the first letter D. We're gonna start with D, and then we have E, right? We're gonna branch out. Is D before or after E? It's after A, B, C, D, E. So we write E here. And then we have L. L goes out. T goes out. A would go here. V goes out. A. If it's the same letter, it's technically counted as before. So we're just going to do that. R is going to be less than T, but goes all the way down. I is less than L, but greater than E. A once again. N is going to be less than R, and T is going to be greater than T. And knowing this, we have to find the internal pathway. So you might be asking, how do I find the internal pathway? It's quite simple. We're going to multiply the number of nodes, and the nodes being the letters, depending on which level they're on. This is level 1, 2, 3, 1, 2, 3, 4, 5. So it's 1 times 2 is 2, 2 times 2 is 4, 3 times 3 is 9, 4 times 2 is 8, and 2 times 5 is 10. You add that all up and you should get 33, which was C. So that's going to be it for the theory section today.